Good afternoon, guys and ladies. I see one. My name is Skip Asay. I'm sure most of you know who I am. Before I go any further, please accept my apologies for keeping you waiting. It's been a zoo for me over there, as I'm sure you've already seen. What I'm going to try and do today is what I think would probably be the most informative way to handle such a thing. There have been 2 or 3 other gentlemen up here giving you information or making information available. The simplest, as far as I'm concerned, is ask me questions about your particular thoughts, your particular area of concern or whatever. It's a sure bet, whatever question you might have, there are probably a whole bunch of other people, probably right here in this room, that have the same questions. So we'll be able to address the necessary areas as much as I possibly can. Okay, waterproof adhesives. For holding together a fiberglass hull, joining together 2 pieces of fiberglass or 2 pieces of plastic or whatever, depends on the application itself. If it's the hull, the 2 hull halves, then yes, Versalock works very well. Epoxy works very well, but it's not the 5-minute epoxy. 5-minute epoxy is not waterproof. It will, over time, absorb water and delaminate, and you've got 2 pieces instead of 1. And invariably, that always happens at the worst possible time. Trust me. 15-minute epoxy really comes under the same heading. It's really not that waterproof. The best is when you start getting into 2-hour and 6-hour epoxies. They are waterproof. As with anything like that, even polyester resin, by the way, fiberglass cloth, but the polyester resin is not really waterproof. Over time, it will absorb water. That's why full-size boats, you always hear about gel coat. They've all got a gel coat on them. That's there to waterproof it. That's there to keep the water from actually reaching the fiberglass cloth itself. Now, for holding bulkheads inside the boat, now you're not worried about being able to sand a seam and get it really smooth so you can't see it. Silicone works incredibly well because it's a flexible bond, it's a flexible seal. To get away from the hard stuff, the Versalock and the polyester resin and the epoxies and everything else, for sealing your pressure-held bulkheads into position, what I like, what I'm real comfortable with, and it's proven to be just about bulletproof. This is the bulkhead itself. This is your hull. The pressure hull is literally that. That's the dry part. That's the part you don't want to see any water. And this is, of course, free flood. What I'll do is I'll put the bulkhead in, and if necessary, maybe tack it with some CA, some gap-filling CA, but just something to tack it to hold it into position. That's all it's there for. And then all the way around, and this is single-dimensional, but all the way around the hull. So front view, this would all be a nice fillet of silicone. Just work it right into the gap. Just make sure it sticks on both sides, both to the whatever bulkhead material you're using, whether Lexan, plexiglass, fiberglass sheet, or whatever. I don't recommend wood, by the way, under any circumstances. Just a nice fillet all the way around, and then walk away from it. Let it cure. Silicone takes 24 hours to cure fully. You can start working in this respect in probably 3 or 4 hours. But then it's a matter of turn the hull upside down or stand it straight up and pour thickened resin. Again, same thing here, but now you're going to put that on the inside of the hull. And what that's doing is, inside of the bulkhead rather, what that's doing is that's giving you a nice hard saddle. Water pressure is going to be pushing against that saddle, okay, and it's not going to move. Silicone by itself would flex. With the deeper you go, it's a soft material. it'll push that in. What happens when it pushes it in, it's shrinking your pressure hull volume, and the boat's getting heavier. Plays all kinds of havoc with your trim. Doing this in here is not really, if you use like plexiglass or Lexan, that's not necessarily going to stick to it. But it doesn't have to. That's holding it in place. It's keeping it from going in. It's keeping it from shrinking. The silicone is what's doing all the sealing. Let me explain why I like to do the silicone for the actual sealing itself. My boat, that's the way I carry it, my saddle, yeah, sometimes the foam rubber comes out. And driving to or from a lake, it comes out. Now the boat's banging in the saddle. That's shock. Shock can, over time, break that loose. It'll crack it. It will not affect the silicone seal. So it might debond this to the point that you could actually get behind it and push the bulkhead out a little bit. You're not going to push it very far. But pushing it out is no problem. That's not going to hurt you. But you're not about to push it in. And neither is the water when you get in the water. Water pressure will not affect it. It will not hurt it. So it's a nice soft seal. Staying with the adhesive, that same adhesive question, what adhesives to use. Come back to silicone again for motor mounts. Mounting whatever, servos, anything inside the boat. Silicone is something that's really quite strong for the usage that we give it. That's the key part. The usage that we give it. Silicone will work wonders. By the same token, unless you've gone overboard with putting silicone on it, you can break it loose. Or take an X-Acto, slit it, bang, you've got it apart, you've got your piece. A little bit of scraping, you get it cleaned up. For motor mounts, what's nice about that is, this is just a generic thing. This is the motor mount bracket. That's the motor itself. What I like to do is put a piece of whatever. I'm a firm believer in Lexan or plexiglass. I love the stuff. Mount that either with silicone itself to the hull or however it works. And then another sandwich of silicone there, but just spots, 4 corners. 4 corners. Now what have you got? You've got a soft rubber insulator. So any little vibration is not going to be transmitted throughout the whole boat. It's going to be isolated in that one spot. Motor mounts in a car. It's exactly what they do. I used to drag race, and one of the first things you had to do was lock up the motor mounts. We replaced them with just steel brackets. Well, I tell you, you feel everything. You feel every loose valve. It goes through everything in the car. It's the same thing here. You get a motor mount, a motor that's got a little bit of imbalance in the gear drive or in the prop or whatever. If it's hard mounted, that vibration is going to go throughout the whole boat, and you'll end up over time, things are becoming loose. It's not like with a model helicopter or an airplane, but if you spend enough time in the water with any particular boat, like I do, yeah, you have to worry about that stuff over time. 4 little spots like that in this area here, and bang, you don't have to worry about it. You have to take the motor out, an X-Acto blade. Okay, carry it another step further, 2 pieces and a sandwich, same basic thing, but sandwich, but another piece up top here, and 2 bolts or 3 bolts, whatever you need. It'll unbolt, unscrew, and you have the modularity. It comes apart very easily, but you still have the soft mount. What other applications? My pet, and a lot of people get on my case about this, putting the deck lids on top of the pressure hull. I do not like to use 4,986 440 or 632 or whatever screws holding this thing down. The reason for that is, with time, that's exaggerated of course, but that's what the Lexan lid looks like, or the plexiglass. There's a nut, there's a nut, there's a nut, there's a nut. Okay, what happens here? Over time, guess what? You're going to leak. Plus the time element, you know. What I do is the hatch combing, which is the highest part of the hull itself, the pressure hull itself. I like to split my boats at the waterline. I don't like pressure hull above the waterline. Okay, so I split it there. Hatch combing, which is part of the boat, and I do the same thing, by the way, except there's a gap there and I fill that gap with silicone so it's flush like that, but I still have that fillet underneath. Again, the same thing, it prevents it from crushing down. But I will then take my Lexan lid and put a thin 16th to 3/32 bead of silicone all the way around that lid and just drop the plate on it. Put some weights on it to make sure it's secured all the way around, walk around, give it actually a thin bead like that. You can give it 15 minutes and put the boat in the water. Silicone still does not cure fully for 24 hours, but you can do that. It's not recommended unless you absolutely have to. And then a bottle cap. Now you have access to the pressure hull. You can reach in with an ear syringe or whatever to get out any water that might have leaked in, which by the way shouldn't happen anyway. And on-off switch, charging jack, hull ventilation as far as fumes are concerned. Any moisture that might be in there, it gives it a way to get out, and you're covered. How do you get it off? You glued it on. It's split the hull is split at the waterline, and that piece is actually, if that Lexan lid is a 1/4 inch thick, that piece is a 1/4 of an inch above the waterline. An X-Acto blade stuck underneath, and just go sh, 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 and there you go. It's off. A single edge razor blade, you scrape it a little bit, clean it up, put another bead, plop it back down. It takes a little bit longer, but then again too, I've seen some guys spend an awful lot of time taking their hatches off and putting them back on again when they're talking about all those nuts and all that stuff. So, matter of personal preference. Throughout all of this, what you have to understand is, besides the fact that I can be very opinionated, matter of fact, I flat out am very opinionated, but it's based on having done this stuff for a good many years. And when I get into something, when I do something, I do it whole hog. I don't play with my boats once every 3 months. I'll generally be in the water once every day. And so I've learned an awful lot of these lessons the hard way. What is simplest? What is most reliable? Easiest to work with? Carry it in any direction you want. This is what I have found over the years works the best for me. Some guys are really into screwing their pressure hull lids on. God bless them. Same thing holds true for you. Have I given adhesives enough? Adhesives maybe for the difference between CA and stuff like that for doing detail stuff. I'm not into detailing. I usually end up hating that with a passion. I do it, but boy, it's hard to get me to do it. When I do it, I'll go hellbent for election because I want to get it over with in a hurry so I can get on to something that to me is more important. CA over time, by the way, it's great in our applications, but if you lose a boat and it stays down at the bottom for a long enough period of time, and I'm talking weeks, you might be missing some pieces when it comes up because CA will break down with water over time. Pressure hull setup. Basically, that's a matter of personal preference. Whether you have one ballast tank and 2 pressure hulls, 2 ballast tanks and 1 pressure hull, or a combination. Imagine that that's a submarine. I told you about my artistic abilities. You can carry that one step further, and I've seen one pressure hull, one ballast tank, and then a battery, and then a lot of foam. It's really a matter of personal preference. Some people like the feeling that 2 ballast tanks are safer or better than one, because if one malfunctions, you got the other one. Very seldom, if ever, true. A model submarine is just like a full-size submarine. There's very little reserve buoyancy. So if you have 2 tanks, the chances are the one tank is probably going to be enough to take it down, certainly to make it unmanageable. If this were a ballast tank in this area here, and this were a ballast tank here, if you lose this flotation here, guess what? That boat's going to be looking like that. What are you going to do? Go for a swim or get a boat out there. There's no way to control it. So what have you accomplished? Okay, granted, the boat has stayed on the surface. You can see where it is. But even then, not always. I can remember spending an awful lot of time swimming through some water looking for a boat that should have been over here. The purpose of a ballast tank is to offset everything that is above the waterline, okay, the displacement of everything that's above the waterline of a submarine. Everything. Every stanchion, every square inch of deck, cubic inch of deck, everything that there is above the waterline. With the conventional type submarines, there is almost always much more deck area ahead of centerline. It's higher out of the water, wider, there's just more of it. Conning towers, Fleet boat is an excellent example. Conning tower is way ahead of midships. But then when you go back to the stern, the conning tower, which is the single biggest piece there is above the water line, is way ahead of midships. And when you get back here, now you're talking very slim. The deck is lower to the water line. I mean, there's just a whole lot less there. Now, how does that relate to ballast tanks? To get a boat to dive in a scale-like fashion, the bow goes underneath first. To surface, the bow comes up first. That's just the way they do it. Okay? With 2 ballast tanks, what you have to worry about is this tank up here has to flood a little bit quicker than the stern tank, and it has to blow a little bit quicker than the stern tank. Can't be the same. You can't take 2 exactly identical tanks and put them in one bow, one stern. You're going to have a mismatch because there's a whole lot more area here that's got to be catered to, and you need more speed, both blow and vent, okay, up here. Now you get into a balance problem. Well, do I shrink this hole a little bit? Do I enlarge that hole a little bit? Why bother? KISS. Okay? Keep it simple. With one tank, basically a midships, it'll be a little bit ahead of a midships, especially in that type of a situation. You establish that in the very beginning. That is the center of flotation, is what that's called. You establish that, and then from there, dynamically, which takes very little, just a touch of stern planes to raise the stern, a touch of bow planes to drop the bow, whatever. It does not take a whole lot. The boat will move just that way. The bow will go down first, the bow will come up first. Nice and scale-like. What you're also looking at with is if you use a compressed gas system, you've really only got one system. One ballast blow, one ballast vent. If you have 2, you have double the chance of problems. And yes, there's certainly going to be somebody who's thinking, well, wait a minute, if I have 2, I have a fail-safe, a backup. Point taken. Okay, but so what? If you build it, if you take your time and build it all properly anyway, the chances are very slim that you'll have a problem in that respect. So Always have to take into account Murphy's Law. He's always there. That little bugger just never leaves anybody alone. My recommendation on a ballast system is always a compressed gas, propel. When I say propel, I mean specifically any airbrush propellant. Propel is one, Testers makes one, Pache makes one. They're all the same basic material. You're looking at 50, 60 pounds per square inch pressure, liquid under pressure, which expands considerably. Tremendously is really the word to use. Again, I'm very opinionated. That's all I use. That's what I like. I like that because I'm very familiar with it. I like that because it's very simple. I like that because it has a fail-safe in that if you get stuck in some weeds and you blow ballast, the chances are, because you're giving the boat so much extra buoyancy, and there is a lot of buoyancy to be had when a boat's down that low. Have somebody operate a boat sometime and you take it down and then have them blow it and try to hold it down there. You're going to be hard pressed, you know, a 5 or 6 foot boat. Worst case scenario, and I've had to use this, is the boat does get stuck in weeds and it won't come up. Okay, it's really got some killer line wrapped around it or something like that. You've got a bubble path. You know exactly where the boat is. You might not be able to get it, but you know exactly where it is. So when you call your diver buddy, or when you go over in your car, and like so many of us old-timers are, we come equipped with masks and fins and towels, just in case, okay? I got my suit on. I've gone swimming many times, so I know. The time it takes for you to go over and get it and everything else, you're still you might be off 5 or 10 feet, and if you've got water where there's the clarity is only good for 3 or 4 feet, you could be that far away from it and not see it. But you've got a compressed gas on board, you can leave yourself a bubble so you can see right where it is. I had that happen to me exactly that way. You couldn't see 3 inches in front of your face. Not 3 inches with a mask. I had to hire a diver to get this. And left him, I had to leave him 2 bubble paths, and then he finally went right to that spot, left him one, blew right in front of his face and went down and got it. But otherwise there was no way he would have been able to get it, because you can't see. Okay? So there's that extra. With pumps, with a pump type system, you absolutely have to have something sticking above the surface of the water to pull the air in to displace the water. You've got no other choice. So if you're stuck in weeds, you're down there for the duration. A compromise, and a very good one in a lot of instances, is an angle type of system where it's a moving piston. It's a cylinder. I haven't seen it anything but round that has a moving piston. Usually have an O-ring around here, threaded rod. As this moves this way, any water that's in here is getting pushed overboard. But that, by the way, is the only tubing. When it pushes this way, it's pulling water into here and compressing the air inside the hull. With this system, you never have to worry about running out of gas. You do, however, have to worry about running out of battery, because these things, for the most part, on average, use a lot of current. So if you haven't kept track of it and you've been doing more diving and surfacing than normal and the battery's starting to get weak, now all of a sudden you get stuck down at 10 feet, well, you've got pressure behind here, what pressure you built up in the hull, but maybe 10 feet, that pressure that's against here is more than what the motor with low battery voltage, with almost dead batteries, might be more than it can overcome. Of course, if you're at 2 or 3 feet, it's not a problem. But everything has a drawback somewhere. Everything has a good point. My own personal, like I say, is the gas. Find something that works really well, you stick with it.
Get that clear.
The difference between bow planes and stern planes and their applications and so forth and so on, my experience has been, and it's documented, it's by full-size submariners, the stern planes, and from what I've seen also, it really doesn't make any difference whether it's a nuke, teardrop-shaped hull, or a conventional submarine, a fleet boat, U-boat, whatever. The stern planes are always more sensitive. They'll do more for a given amount of movement than the bow planes. Okay, now, a conventional type of boat that has the stern planes behind the screw, well, of course you're going to get the prop wash coming off the screw, which has a whole lot more pressure on it. It is supplying a lot more pressure to that control surface than something that's ahead of the screw. Well, that's certainly going to make it more sensitive. But even even a boat that has them up here, it's still in the stern. They are more sensitive. A boat, and I only just learned this a few years ago, this is a top view. There's a low pressure area, which is something along these lines. Look at the idea, not the quality of the drawing. This is a low pressure area. This is the bow. But this is a low pressure area. So if you have a bow plane right here or here, it's really not going to do a whole lot. This part will, and back a little bit further, this part will. Okay? If you had, and I did this for a research boat that needed really good handling on the bottom, had to be able to move around, but it also needed to be able to move at speed, you know, cruising speed at other ranges. Had a bow thruster right up here, that far away from the bow. That boat, as soon as it had any forward motion at all, and I mean any forward motion, activate the bow thruster, and it was a homemade thruster, and it was much more powerful than it needed to be, this boat would go as straight as an arrow. I mean perfectly straight. But it left such a wake coming off to the one side, it would knock your eyes out. I mean, it's moving a hell of a lot of water, but the boat's still going straight as an arrow because it was in that low pressure area. Stop the boat and hit the bow thruster. If it had a crew on it, they'd have to be strapped down because that thing would whip around like a propeller. Going in reverse, same thing. Going in reverse. Now this low pressure area isn't here. That boat would whip around much better than the rudder could ever hope to turn it. Give it the slightest bit of forward way, nothing. Okay? Planes are about the same thing. This will give you your action, that area, but not this part in here. The further back you go, you have run into another problem. This is basically the axis of rotation. The further back you go, there's that much less distance between here and here. Shorter lever arm. But the distance from here to here is quite a bit greater. So it'll move it much better. In general practice, what I've found is this is what keeps the boat level. That's where you maintain your level attitude. And then you change your depth with this, with the bow planes. As far as connecting them is concerned, one channel, one servo, or even two servos, but still one channel, you get into a balance situation. The bow planes are nowhere as near as sensitive as the stern planes. So how do you set it up? These move 50% for 25% there, okay, to give a number. Well, okay, that's going to be good at a certain speed, but what happens when you go faster or slower? It's not going to be matched. Simplest is separate them. Stern planes, bow planes. Use one to maintain the attitude of the boat, regardless of depth. One to maintain the attitude, and the other one to maintain your depth. As far as bow planes and stern planes are concerned, if it's at all possible, it's not always possible. Sometimes you only have a 4-channel radio. But if it's at all and even with a 4-channel radio, if you only have one set of planes, one channel available, I recommend that you just use the stern planes and let the bow float. It's not the best, but it'll be better than one channel and two sets of planes, whether it's one channel and 2 servos or one servo with linkages going fore and aft. The function is still the same, okay? But absolute best on a boat that has bow and stern planes is to separate them. As far as that is concerned, when you start getting into sailplanes, especially with some of the nukes that have the sail back pretty far, I have not built one myself. I've never built one of those myself. I've seen a few of them, and Mike Dory, who has built like this, they're not really very functional. They really don't do a whole lot because, again, look at the distance between here and here. There's no leverage. They will move the boat eventually. Eventually. The further apart they are from each other, center line of the shafts, the more action you'll get, the more leverage it'll get.
Closer.
But if it's close, it's not going to do anything. My Type 2, the screws are, I think it's 2 3/4 inches apart. The shafts, 2 3/4 inches apart. I tried that, individual speed controls. Well, go one ahead and one astern, and put the transmitter down and go over and have a conversation with this guy over here, visit the head, and come back, and it's maybe moved 45 degrees. Waste of a channel. Absolute waste of a channel. A Typhoon has quite a bit of space between them. That might work. It'll certainly work better. Okay. How much better, I don't know. I haven't built one. If you have counter-rotating screws, the starboard screw will go like that. Yeah. And the port screw would go the opposite. Go out. We're looking from the stern. Okay. Counter-rotating. I'm sorry, counterclockwise, clockwise. Looking at it from the stern. Yes. This is a stern.
You're in the water.
I'm in the water. I'm looking at the screws. The bow is over at the other end. Then yes. This would go clockwise, and this one counterclockwise. A nozzle around a prop.
It's just like a speed field that they have.
Like that, correct? A tube, piece of tube. Basically, that'll give you a little bit more thrust at lower speeds, because what happens is when a prop turns, there's water, besides the water that comes off this way, okay, there's water that also comes off straight that way. The nozzle will capture this and push it out back. At higher speeds, I would imagine you'd get into a drag situation. The nozzle itself, just the material of the nozzle itself. A quart nozzle will definitely give you better directional control going in reverse if the nozzle itself turns, because then it's directing that flow off in that direction. Okay? But I personally build everything with as low current draw as possible. I'm a firm believer in not over-motoring. I'm a firm believer in not over-propping. If it's got a big prop, coarse bladed, coarse pitch, I'm not going to put a bigger motor in there to turn it. I'm going to gear the motor that I've got down. The bigger the diameter, the coarser the pitch, the slower you want to turn that prop. So I'm not going to put a Corvette engine in a Hyundai to try and get gas mileage, is really what it amounts to. Okay? The bigger the diameter and the more blades you've got, the coarser the pitch, the slower the prop has to turn. The slower the prop should turn for maximum efficiency. So if you have, say, a Pitman motor, Dumas motor, to give you an example, my Type 23, most of you have seen at one time or another, 24th scale, 58 inches long, has a 2 3/4 inch, 3-blade, very coarse pitch prop. I can't tell you what numbers, but the prop was originally for steam tugboat, really, but it sure does look an awful lot like the original one, so I used it. That thing, I started out life a bunch of years ago with a have to think about this now. It's a 4-to-1 reduction. Pitman motor on 10 volts. The boat, anything above about 3/4 throttle on the surface, the boat wanted to dive because it was just going too fast. And I didn't measure current draw at that point. A year or two later, I changed it and went to 5-to-1. I noticed more time in the water, but the boat sure didn't look any slower. Okay, but I was able to stay out longer. Time progressed. I went to 6-to-1. And geez, you know, I'm from 4-to-1 to 5-to-1 to 6-to-1. The boat's not going any slower. Full speed, it still wants to dive on its own. But I am picking up the benefit of now it wants to stay in the water much longer. I don't have to pull it out after an hour, hour and a half. I can stay for 3, 3.5, 4 hours. Wow, you know, there's a big difference. So finally the light bulb came on, and well, you know, let me investigate this. So I built a test tank, big old 3-foot diameter round tank, and set everything up. And I could read current draw, I could read RPMs, prop RPMs, and of course voltage at the battery. I did not use a speed control. For absolute repeatability, I used individual 2-volt cells in parallel, 10 amp capability per cell, so I could read it at 2 volts, 4 volts, 6 volt, 8, 10. And each time I would always return to, if I wanted to read the 2-volt speed again, I knew it was coming back to 2 volts. Well, that thing at 6-to-1, I forget all of the numbers except for this. When I went from 8 volts to 10 volts, the prop RPM did not increase at all. But the current draw, like that. But the prop RPM did not increase a bit. 5 RPMs maybe, okay? So I got to playing. I took out a whole bunch of stuff that I had laying around. I've accumulated a whole bunch of gears and belts and stuff like that over the years. And I put myself together an 8.3-to-1 gear reduction. Compound belt drive deal. I mean, it was not something I was going to put in the boat as it was, but it gave me an 8-point-something-to-1 reduction to the screw with the same motor, same voltage. And I started reading it, went through the whole test all over again, 2, 4, 6, 8, and now the big test, go from 8 volts to 10 volts. And gee, guess what? I now had at 10 volts the same RPMs that what I used to have, that what I had previously at the 10 volts, okay? But I went from, and these numbers I can remember, that was drawing, originally at 6-to-1, I was drawing 1.9 amps. Okay, it was 1 amp at 8 volts, 1.9 amps at 10 volts, with no increase in prop RPM. So I doubled my current draw, okay, with no gain. And this was in moving water now, not just stagnant water. So the 8-to-1 at 10 volts, I still had the same prop RPM as what I had previously, 1 amp. .988, okay, is the exact number if you want to get technical, but 1 amp. I cut my current draw in half compared to what I had it at 6:1. But the prop RPM was the same. Guess what? The boat didn't go any slower. Yeah. To the extent that I could stay out in the water long enough that I had to end up putting bigger batteries in my transmitter to get myself time, because I didn't have to worry about the boat running out of power. The transmitter was running out of power. This is a 7805 regulator. Radio Shack is 276 1770. They sell for, I think it's $1.59. Here comes the difficult part. You have to take a capacitor. This is, by the way, this is, you hook this up to 12 volts. Number 1 pin to 12 volts. This pin right here is your 5 volts out. This pin right here is ground, your negative, black wire. Okay? You take a capacitor, about 0.1, and you hook it up between those 2 pins. Then you take another capacitor, same thing, 0.1, and you hook it up to those 2 pins. You now have a 5-volt battery eliminator. It will give you between, I've never seen anything less than 4.91, and I've never seen anything greater than 5.05 out of it. Okay? That's exactly what we need. 5 volts. And that's it. You don't need anything. Okay, I'm sorry. I take that back. I don't know the part number. Radio Shack has them. Heat sinks. But if you're going over into the area to get this part number right here, 276, right alongside of there someplace, because it also has a 276 prefix in the part number, is a TO220 heat sink. They're all of, I think, 49 cents, something like that. And that's it. Unbeknownst, that already has thermal limiting in it. The 7805 has thermal limiting built into it. So if you don't put a heat sink on there and it starts getting hot, it will get hot. And when you start moving servos and stuff like that, it will get hot. And it'll finally get to a point where it'll say, that's it. I'm not giving you another dime until you let me cool off. And then it cools off, and then it turns itself right back on again. Okay? Onboard thermal limiting. No extra circuitry, no thermistors, no nothing. You got 4 components. 1, 2, 3, 4. I think maximum cost, if you go to Radio Shack, if you go to Radio Shack up in Canada where they get about double what they get down here, you're looking at maybe $4.50. So down here, I think the 7805, I think that's $1.49, somewhere in that area. The caps, you can get 2 of them for 59 cents. They come 2 to a pack for 59 cents. The heat sink, if it's $1, what are you looking at? And that's it. Now, it is important, 75% of the time, and I do have to say it that way, 75% of the time, to put caps on. Not always. I've built a bunch of them without them, and it's worked great. I have no problem. I've also built a couple that doing weird things. I mean, killer weird things. A variable voltage supply going into it. Increase the voltage up from, I had the voltage set for 5 volts because I was doing something else. And I read the voltage out, and it's 4 and something. Well, okay, these things need a regular 7805. It's recommended that to get 1 amp current through it, you have a minimum of 7.5 volts going into it. Okay, you can get away with 7. You can get away with less if you're not drawing a whole lot of current through it. Not recommended. But anyway, I got it all hooked up. I'm checking my voltage out, and it's out in left field. But okay, I know this. You need the extra voltage going in. So I start cranking up the voltage, the power supply, and it gets up to 5 volts. Oh, here we go. But I needed 12 volts going into this board, onto this breadboard. So I kept on going, and sure enough, I'm looking at 4.4. But wait a minute, it was just at 5. That drove me crazy for a while, until I put the caps on. Put the caps on, bang, killer, right there, dead nuts, right on, never varied. I've probably put together for myself and for other people in the last 15 years, and for anybody who's doing their math, I said before I've been putting these things in the water for 16 years. I also said I started using these my second year. In that 15 years, I've probably put together 150 of them. And I'd say probably 5 of them I have run into that problem. They needed caps. Okay? So put them on anyway. A 7805 is capable of oscillating. It'll pulse a little bit. Can screw up your signal, your receiver. Put them on and you don't worry about anything. Bang, that's it. Forget it. It's all over. Battery eliminators. Okay?
Which one you prefer?
My own personal preference as far as batteries is concerned is the Gates sealed lead acid Cyclone cells. What's nice about those is you can adjust your voltage to whatever you want. The 23, I had X amount of space inside the hull to put batteries, stacking them up. They make these in a D cell, which is 2.5 amp hour capacity, which is the size of an alkaline D cell.
Yeah.
The X cell is actual displacement is twice as much. It's also got twice the capacity. It's 5 amp hour. And then I know they have a J cell, which I think is 12 amp hour, and there's something else that's 25 amp hour. We're getting into some expensive stuff. Anyway, this is not accurate, but with the 23, I only had enough room. Yeah, it is accurate. The only room I had was to put the 6th cell was there, and that would put it above the hatch combing, the hatch line. So I ended up with just 5 cells, but I could do that. It's that simple. Sometimes in the boat, let's continue this. Sometimes you might want to put a cell here, here, and so forth down the line. Center of gravity is important on these boats. Okay? You have to get the weight down as low as you possibly can. The best way is with these type of, if you're using these type of battery, this type of battery, is to lay them right down in the keel and then go end to end. Everything is going to be down low. You can see the difference right here. There's your keel. The higher you go, the more you go, the higher the center of gravity is. And guess what? What are these things made out of? Lead, acid. Okay? The higher you put it, you're putting a heavy material up high. That's a no good. So now, what's nice with these particular is you can mold them into the hull. It's a whole lot easier. I'm going to take some artistic license here. It's a whole lot easier to put a round peg in a round hole. Now, fine, you're putting a bunch of round pegs in a large round hole, but you can get away with it like this. A rectangular battery is going to be up here. I should have just erased that, shouldn't I? But you're going to have dead space here, point contact here, and what are you going to put in this area? In some boats, you can't put anything. Got a lot of wasted space. Now you're also, for that same amount of area, you're looking at something that's taking up a lot of length. In some cases, Or you could put a battery cell, a single cell, real nicely here, but only one. But you need a lot of weight in the stern. Well, okay, I can put 5 more of them.
Just like ballast. Like
Yes.
balance it out.
Use them as ballast. This is the best ballast there is. It's a functional ballast. You can put these cells outside.
Contact of the battery will seal.
Well, it's not just, you don't want to just seal the contacts, but you want to seal around. They have a sleeve.
Just like that.
So it's like anything else that you have to seal up. The solenoids for ballast systems or whatever. Every place that there's a gap, any kind of a seam or whatever, you have to coat it with, just fill it full of silicone to seal it up. Putting these things outside the pressure hull can be done. It's like any other battery. It can be, or sealed battery. They can be put outside the hull. It's not something that does a whole lot for me. I don't really see a need for it personally, but again, guess what? Personal preference. All batteries will give off gases if they are over discharge, high rate discharge, or high rate charge. Whether they're NiCads or sealed lead acid or maintenance free this or that or the other. If, in our application, if you over discharge at high rate, you pull 10 amps out of a 5 amp hour battery, it's going to end up giving out some gas. These sealed lead acid gates, individual cells, will take that. They'll do it. You can charge these or discharge these as much as 25 or 30 amps. Okay? Got to be awful damn careful. But they will take it. These tabs, by the way, are fusible links. They will break. They will desolder themselves at 50 amps. Gates did that on purpose. Designed it that way. Because these things will dump that kind of current. You can weld with these. But any battery, whatever the make, whatever the type, will give off gas if you put too much current into it at too high a rate, or if you try to take too much current out of it. So for charging purposes, that's your safest number. C10, the capacity divided by 10, or 10% of the capacity. It's the safest way to go. You can't get into a problem. If you discharge, if it's a 5 amp hour battery, personally, I like to see a maximum of 1 amp coming out of it at any given time. That's C20, but or actually C5, I guess. But it's still safe. You're still covered. You should still have, by the way, plenty of ventilation just to be on the safe side. I personally don't like grease stuffing boxes because there's friction involved in the first place. The grease in the stuffing box there's supposed to be a shaft going through there, but again, artistic license. If you fill this area with grease, these are your bushings, the oil-like bushings at each end. This is the shaft, obviously. You fill this with grease, and yeah, where that water's got a long ways to go before it gets up to here. This is the inside, the pressure hull. Okay, P hull, dry. It's got a long ways to go through all that grease, and everybody knows grease is waterproof, right? Or grease can be waterproofing, okay? The problem is, if it can get in past this bushing here, and it will because there's clearance there, no shaft will turn in something without a clearance. If water can get in here, and you got the same thing down here, I bet you something could get through here, couldn't it?
You're under high, like,
When you dive, when you take it down to any depth. So what's going to happen? It's going to displace, you're going to get water here, and it's going to be pressing this grease, and you're going to get grease out here. And that's inside the boat. Grease flopping around inside of my hull just doesn't do anything for me. Not a thing. So I like a seal, some kind of a seal. And O-rings, an O-ring type of seal is one of the seals that has been used for many years and used well. And these bushings, by the way, do wear out over time. They're not supposed to, not for a long time, but they do wear out pretty quick. So that grease does, by the way, supply a lot of lubrication as long as it's nice and as long as it's loose, but that's about all the good you get from it. Okay, suppose you built all the way to here and to there. That's all pressure hull. Solid, right up to the nose. Free flood, pressure hull, free flood. Right off the bat, you're going to have to add an awful lot of weight up here to offset that, because that's going to be buoyancy. Okay, that's going to supply buoyancy because it's all sealed up. Now, in the stern, you're going to have to be real light. Well, you're going to have to be. You're going to be getting into a matter of leverage. One. Got a big old brass screw back there. That's as far back as you can get. Go back to leverage. It's as far as you can get. It's going to make the stern go down. You've also got free flood here, but you've got buoyancy here. There's a distance. And you've got a lot of buoyancy here. You're definitely going to have to do some playing games with adding lead here and there and the other place. But also, where the ballast tank itself is, which is your center of flotation, is going to be different from normal. Different from what it would be if this were free flood here and this pressure hull. Because this is going to be offsetting. So as far as having too much and too little, if you have too little free flood area for a given size boat, you take a 6-foot long boat and you don't have a whole lot of free flood area in there, you're going to have a boat that is going to take 3 men and a boy to get down to the lake and then get back again. Okay, it's just going to have to be so heavy to offset all that pressure hull volume. As far as too little free flood, I'm sorry, too much free flood is concerned, all that's going to do is it's going to make your pressure hulls really small, so you might really be packed too tight. You still have to put batteries in, you still have to put servos in and speed controls and a receiver and those things. If you pack them in too tight, that would be the problem, just that they would be packed too tight. But as far as operation is concerned, that won't affect it, as long as your balance is good. The layout between where each of the pressure hulls is in relation to the center of buoyancy, center of flotation. What else we got? No more questions? Let's go home, or back to the lake.